Alright, welcome to the second video that's related to materials and material mappings in Brazil for Rhino. So I'm going to move to the right here really quick, and here you'll see a couple examples that are related to the texture gizmo manipulation. And as you kind of saw earlier, it's actually pretty easy and intuitive. But I'm going to select these guys and show their mapping, and you will see as I actually just select them, you'll see that basically the default we saw earlier, this is a box mapping, roughly double its size. This is with the box rotated one direction versus the other, right? This is rotated on the vertical axis, this is on the horizontal axis. This is a spherical mapping applied to a box, a spherical mapping that's been scaled. Remember that with these, you can also still apply, basically use the gizmo to scale it as you would normal geometry. Okay, now let's take a look at what that looks like really quick. So in rendered mode, you'll see that as before, this is what happens, and as before, when you scale something non-uniformly, this is what happens, right? So in this case, you'll see that if I scale this, initially this will change with it. The widget is sort of tied to the geometry in this case, but I can always come back here in the XYZ size and put this back to 15. And actually you want to make that consistent, so and revert it back to 15, and you'll see then you can actually apply it in a way where the sides actually are or the sort of subdivisions are consistent, right? And then obviously the rotated versions kind of just show you what happens when you rotate in the different directions, and the sphere, you'll get this sort of weird stuff on top, as well as when you basically smush it. So you'll get on one side, on the sides, you'll get a much more sort of denser material distribution. Alright, so that's just sort of saying, okay, well, you know, these are things that you can play around with, manipulate, and just sort of see and understand what effects these sort of manipulations have on your material. You know, all at the same time, and kind of understand, even in this case, for example, as you apply these sort of non-linear scalings to it and how they affect the geometry, or how the materials map to the geometry. Okay. Now generally you won't be doing too much of that, and so we'll kind of move on to the next section just to show you. So this is a group of basically, let's say, walls or polysurfaces, as a lot of you probably will have. There are a couple of different size walls. One is, you know, this is shorter, this is long, and the problem with applying mappings like this, more or less individually, and you'll see that this one, when I select it, actually has no mapping applied. So basically what happened is that I just applied the materials to it, right? I applied the material like this, and then by going to Render Shortcuts, Material Editor, and selecting the concrete through right click, assign to selection, right? And I applied it without actually applying any sort of mapping. Now what you'll see is that by default this is what it tries to do. You know, so in these sort of longer sizes it does this, and this sort of small, and I guess the problem, as you can see almost right away, is that I have the same material, but I have 1, 2, 4 different sort of subdivision sizes, and that doesn't make any sense, right? The sort of scale of the either it's tile or concrete panels is just completely off. And so what you want to do is to be able to unify these. So in this case, you'll see that these are grouped and box mapped together, which means I basically selected them all like this, Control G to group them, and then map them as a whole group, which means selecting them as a group and then coming over here saying apply box mapping, bounding box, world, capped, yes, etc. Right? And then now when I switch to the render view, you'll see that, okay, now my tiles are all the same size, right? And if I show the mapping widget, that's what it looks like. So this is what happens when you basically group your objects and apply the mapping together, which is actually a pretty good idea if you want to keep your material scale more or less roughly consistent. Right? Now, the last example here is rotated simply, and let's show the widget. Right? So you can see, in this case, for example, I just didn't want these tiles to run that direction. I wanted them to run this direction, so you can do that. Now, you'll find in some situations that instead of doing these whole things as one group, as I ungroup them, is that you may want to actually find, basically have a way where these sort of horizontals are in their own group and the verticals are in their own group, so you can actually detach this from this. Because let's say, usually these three, for example, vertical walls have one texture scale, whereas this sort of horizontal wall has its own separate texture scale. So that will, in essence, allow you to control these sort of more on their own. And this is just because I changed this to really dense. So, if I lock this and say 30, for example, that allows me to basically manipulate the horizontals on their own if I wanted to do so. And so you'll kind of have to plan and think about, what exactly it is that you need in your situation in these cases. All right. So we're going to move on to the last set up here. So this kind of shows you what to do in some of these situations, especially when you have a diagonal mixed in with a lot of orthogonals. So this is a slab object. The slab object, which you can just type in slab, is used for making walls. If you have any sort of curve, and I'm just going to just draw something really quick, for example, that, and type the slab, slab command, select the curve. It'll show you which side you're basically making the thickness or the offset. So that side, and then you can pull it up or down in terms of the height, and I can just snap to my previous height. So that makes a slab object as a polysurface. This is really useful for drawing walls, basically, that have uniform sizes. It also works pretty well for closed objects as well. All right, like that. Okay, so that's what this is. Now the thing to actually note, particularly about the slab object, is that its corners are mitered like this, right? So you see that, you see that, you see that, and that's how the sort of joints are made. Now that sometimes can be a little bit of a problem, especially with this. So this is the default texture mapping to this slab object, and let's take a look. Okay. Now the curious thing is, and actually this might be a bit more noticeable eventually, but you'll see these sort of diagonal lines, especially not on the sort of side surfaces, but on the top surfaces. That's the default texture mapping, trying to map it to the trapezoid, right? These are, or in this case, the parallelogram. And so your mappings will get distorted, so they're narrower on the inside but wider on the outside here, and vice versa, which is a really weird thing to do, or a really weird thing to see. If you don't see the top of your walls, maybe it's not such a big deal, right? But if you do see the top of your walls, then that can be sort of really weird. So in this next version, this is the same slab object, but with a overall box mapping applied, like this, right? Just the same procedure. And you'll see this. A little bit better, right? These are now straight or orthogonal instead of, weirdly angled. But the problem really comes in here at the ends, where this sort of diagonal section, both number one, your sort of tile size changes because it's sort of projected on an oblique, and on the top where it does this, right? And so that's all of this is fine, probably up to here, right? So the next step that we show is basically a geometry for this that is rebuilt cleanly. So how do you actually do that? So here, let's say I'll take this guy and I'll copy it over. There are actually probably 5 or 6 different ways to do this. I'll show you a couple really quick here. Now the dumb, stupid way is actually just to use your line and basically go through, either extract or retrace the outline of these. And that's the sort of dumb, slow, but kind of surefire way of making sure that things will work. It may be feasible, unfeasible, depending on your situation. So what you would have is then essentially a closed curve like that, which I can just extrude downwards and cap. So what happens is then you would have, okay, this is a completely clean geometry. The lazy way is to just select it and type merge all faces. And sometimes you'll have weird stuff happening with isocurves, but in essence that is a clean continuous surface. Almost the same thing. And usually if I'm really lazy, this is what I would do. There are other ways of basically duplicating face border or edges, and you can just select that, and that would kind of give you the edges as a whole sort of set, except in this case, because these are all segmented. So if I run the same command, dupe face border, I have to go and kind of select these faces one by one, which usually is easier to do kind of in a side view like that. Or you can just sort of select it 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Enter. And before you select anything, just try to move it out of the way so you can see. Dupe face border does that and gives it to you as these sort of closed loops. And so in that case, you would have to explode with the explode command, explode everything, and delete out by selecting these overlaps, right? Now these are all sort of individual segments that you can then select together and type join them back into one, which you can then extrude. My shortcut for extrude is E out into basically a clean rebuilt section, right? So you'll see, I mean, there's a lot of different ways to do this. The quick and dirty, easy way, but you might basically kind of have this weird iso curve, is the merge all faces, and this is a rebuilt extruded version. Right, so that's a sort of modeling aside. You don't have to worry about that too much. Okay, so with default, with a sort of rebuilt geometry, let's take a look at what the mapping looks. Oh, I don't have mapping on this, and so that's what it does. All right, so you don't have control over the scale and size. This still happens. Rebuilt clean geometry with planar, same as you can see from before. All right, same problem. It's looking at it as a one complete object. You'll still get the striping on the sides. And so the last example is basically rebuilt clean geometry, split and rotated box mapping. Now here is what's interesting is that, okay, so we're realizing that you probably just want to separate all the orthogonal from the diagonal. So you'll see in this case, this is its own separate object. That's its own separate object, right? And so in this case, because of that, I can actually apply two different box mappings to it. One that is centered around this, and another that is basically rotated to fit that, right? With the same size, same sort of orientation, but because I can make it independent, I can align it so it seems like it's in the right direction. And so if you look at the rendered view of it, then it will make a lot more sense because, okay, you know, these are all the same size, they're aligned, and it turns with the sort of diagonal direction of the wall. Right? So the way to do that, very simple. And I'll go back to shaded view because it shows a little better what you're doing. Is if you take one of these or any of these that you made earlier, while you were in the process, you could extrude them separately, which is one way. Dupe face border, like that. Right? If I basically draw a line here, between here, and you use the split command, select object to split, select that guy, spacebar, and then split using this. Then I'll get this and this separately. Usually I will join this, draw another line here, use that line to join with this guy. You don't have to worry about the sequence, I'm just sort of showing this, how to do this, and then extrude that. Alright, so that's one way, so you'll have two separate walls, right? The other way to do it is if you have the three-dimensional one, then you can basically draw the line there, right? Take that curve, extrude it through. Usually actually extrude it a little longer below it like that. Okay, and then run the split command on the three-dimensional object, enter, and use this as a cutting object, and then you can delete it, that, and that. Now the downside of this is just that, well, I don't know if it's a downside, but it's just not as tidy as that. You know, you'll have one of these sides is open, right? Whereas in this version that we did, these sides are actually, the ends are actually closed, but that's easily solved or easily taken care of by selecting this and saying cap, and take that and cap it, which will close it off. Right, and you can always just sort of move this back into, move it back into place, snap it back into place. Right, so these two guys, you can then apply a uniform box mapping, bounding box, blah, 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 right, and visualize it. You can make sure, okay, you know, they're the same size. Well, for this one, let's show it as well. For this one, let's hide it because we know that's in the right place. And then this, you can just rotate. Actually, let me move it to this corner, and then rotate it to match that and that. And so when you go to the render view, oh, I didn't even have the materials applied to this one yet. So let's see, Brazil, render shortcuts, material editor, and let's drag and drop that, So that's drag and drop. You can pre-select them, right click, assign to selection, that works as well. And so you'll see in this version, these are aligned, this is rotated, etc., etc. In this version, oh, this scale is completely off, this one is this, right? Okay, so you kind of get the idea. These are some of the strategies you can employ when you run into something like this. All right, well, those are actually some of the basic to intermediate material application and material mapping strategies that you can use within Rhino with Brazil, and actually in almost any other render, the concept and the execution is very similar, probably even if the interface is slightly different. But you know, this sort of notion of mapping coordinates and such is basically exactly the same. All right. What I'm going to show you really quickly actually is two things. Number one is, if you go to the website here, there's a link that will guide you to a page that has both a lot of Brazil materials that you can download and basically load into Brazil. There's these which you can sort of browse through individually, and there's also collections. So if you hover over materials, collections, there are some that come basically in bulk, architectural materials. You can click on this and you'll see you can download as a zip file, unzip it somewhere, and load it into Brazil. And you basically go to the material editor here, say add, right, and you can actually click on this, load from file, and go find a material like this. This is quick glass, which I think I've provided you with in there. And just, you can try it out. I don't think that, oh, it kind of shows up in rendered view, but you would have to actually render it to see what it looks like. And that's how you load a material that you've saved or downloaded from the internet. Just sort of navigate to it and it gets inserted into the scene. The other part of this really is how do you create your own, let's say, concrete material. In the folder that I've uploaded, besides the sort of quick glass material and the sort of larger renders of these examples that we just saw earlier that kind of show this, I have two files, Concrete 3 and a Concrete 3 bump. This is a concrete texture. This is a concrete texture, just grayscale, black and white, and with the contrast bumped up a little bit. And this will serve as the bump map. And so you can create a new material, same, Brazil Advanced, like that. And let's just call it conc for now. C-O-N-C. Okay. And it's gray by default. I don't care about the color because I'm actually going to apply a material, right? So if you, and I'm going to make these smaller so you can see, if you kind of go down into these settings, and instead of looking at that, go down, and in the basic surface parameters here, in the color, empty, click to assign, right? Click there and load from file and go find this, all right? Concrete 3, open. And in the preview, you'll see that this actually updates, okay? Now, the second one, the bump file, goes into here, bump. So click on empty, click to assign, load from file, concrete 3 bump. And you'll see the bump file is actually what kind of gives the concrete its sort of rough three-dimensionality. It will kind of approximate the surface texture a lot more. And all you need is, like in this case, for example, all you need is a combination of these two bitmap textures to get a concrete texture like this. And then you can, you know, try assigning it. And obviously, because the sort of scale of the mapping is completely different, in this case, you might actually have to, and let's close that, come here and, you know, kind of change the sort of sizes, and let's actually lock it. Actually, no, let's make them consistent, lock it, and then make it, let's say 40, no, 40 is too big, 10 or 5, right? And so you can very directly see, okay, that's what's happening. And you'll see this is a very bumpy, or, you know, three-dimensional concrete texture. All right, so that actually covers most of what you would kind of do. Be careful with the glasses, because rendering the glasses can kind of kill your rendering time. Anything with transparency, reflection, refraction will take a long time. So this quick glass should work pretty well. Some of these materials, you know, you can try them out, but I would sort of test them out on their own by just at first, so you kind of know what's going on. All right.